Welcome folks. In this video we are going to look at balancing chemical equations. Now balancing chemical equations is a very important skill that is required as long as if chemistry is or will be part of your life. Now for example, if you look at more concept, there are questions that depends on balancing chemical equations. Organic chemistry, we have some chemical equations that also look at the balancing chemical equation. Now the importance of balancing chemical equation is that we have the atoms for reactants, and we want to make sure that the number of atoms for the reactants equals the number of atoms for the products. Then the first step that we are supposed to consider is that or maybe the step that can help us to make sure that we have the balanced chemical equation, or maybe the balancing chemical equation becomes at least easy for us, is that we need to make sure first we write the correct chemical equation for a compound. That's very important, because sometimes if maybe we are looking at calcium chloride, we know that calcium chloride has a chemical formula of CaCl2. Now, if for instance you write chemical equation of CaCl, so this, since you have forgotten the subscript, these two here can make you to fail for the chemical equation and also for balancing. So make sure that you write the correct chemical formula. Then the other thing that you are supposed to know whenever you are dealing with the balancing of chemical equation is if you are trying to balance, let's say, calcium chloride like this one, you don't have to change this subscript. So the subscript will always remain unchanged. So the number is only numbers are only allowed to put in front of an element or a compound. For example, if we need 2 atoms of calcium and here we only have the subscript of 1, so the 2 cannot be written here. No, the 2 can be put in front of calcium chloride. Now I want you to view this as this. Let's say if we look at algebra, we know that x plus x will give us 2x. So if we get calcium chloride plus another calcium chloride, we get 2 calcium chlorides. So it means that in this compound of calcium chloride there is 1 atom of calcium, then another there is 1 atom. So if we put 2 in front of this, it means that we have 2 compounds of calcium chloride. Now let's have our first example. So the first example will begin with the combustion, and we'll say for propene, so we'll have C3H8 plus oxygen. Remember, oxygen is always diatomic. Then the product will be carbon dioxide plus water. Okay, so for combustion reactions like this one, the first atom that you are supposed to make sure that is balanced is carbon. Now before we balance it, let's check if the equation is balanced or not. So sometimes you may write an equation and only to find out that that equation is already balanced. So let's check if it's balanced. So we'll begin with carbon atoms. So on the reactant side we have 3 atoms of carbon. On the product we only have 1, so there's only 1 here. Then what of hydrogen? So 8 atoms here, then 2 atoms here, so hydrogen is not also balanced. Then oxygen we have 2, then here we are going to have 3. Where is 3 coming from? 2 atoms of oxygen from carbon dioxide and 1 atom of oxygen from water, so 3. So we can totally see that everything is unbalanced. Now what is our first atom that we are supposed to balance here? Is carbon. So how can we balance carbon? So we get this number 1, we divide into 3. So 3 divided by 1 is 3. So it means that we need to multiply by 3 so that we get 3. We put 3 in front of carbon dioxide. Now, the oxygen is easy to balance because on the reactant side is just on its own. So whenever you have an element that is on its own, that one will not give you headaches to balance. So focus the elements that are found in a compound. After we're done with that one, we now look at hydrogen. So hydrogen will have 8. So let's divide by 2. So 8 divided by 2 is 4. So this 2 must be multiplied by 4 to give us 8. So we put the 4 in front of H2O. Now hydrogen is balanced, so is carbon. Now we check for oxygen. Now let's look at on the product side. So 3 times 2, we have 6 atoms of oxygen. Then 4 times 1, we have 4. So 4 plus 6 is equal to 10. Then here we only have 2, so we'll say 10 divided by 2 is 5. So this one must be multiplied by 5 to give us 10. So we need 5 in front of oxygen. So this is the balanced chemical equation. Let's have the second one. So the second one, look at butane, where we have CH4, then H10 plus oxygen will give us a carbon dioxide plus H2O. Now for combustion reaction, it doesn't matter the number of carbon atoms that we have in the hydrocarbon. The products will remain as carbon dioxide and water. Now remember, first we need to check if the equation is balanced. So let's begin. We have 4 atoms of carbon on the reactant, then 1 here, so it's not balanced. Then what of hydrogen? 10 atoms of hydrogen here, then 2 here. Oxygen, 2 from this side, then 3 from this side. So let's begin by hydrogen. So we divide by 1, meaning we need 4. So it's 1 times 4 is equal to 4. So we put 4 in front of carbon dioxide. Then we go to hydrogen. So hydrogen we divide by the lowest number, which is 2, giving us 5. So we need 5 in front of water. Now if this is the case, then we are supposed to now check for oxygen. So oxygen is 4 times 2 is 8. Then 5 times 1 is 5. So 5 plus 8 is 13. So on this side we have 13 atoms. Now 13 atoms, 13 is an odd number. So how do you deal with odd number? So if we are to balance this one, we need 13 over 2. Now we don't want to use the fraction. So how do you do if you balance some atoms and the remaining atom or atoms requires a fraction? So what you're supposed to do is you need to multiply everything by 2. So the first one, the 2 will multiply with this one. So the balanced chemical equation will be 2C4H10 plus then if we multiply 2 with 13 over 2, the 2 will cancel. This time we need 13 in front of this, right? Then the second is now 2 times 4, giving us 8 carbon dioxide. Then 2 times 5 will give us 10 molecules of water. So this time the equation is balanced. If you want, we can check. We have carbon, which is 8 here, carbon 8 here. Hydrogen, it's 2 times 10, which is giving us 20. Then here it's 10 times 2, giving us also 20. Then for oxygen, we have 13 times 2 is 26. Then here we have 8 times 2 is 16 plus 10 is giving us 16. So our equation is now balanced. So now we move on to, let's say if aluminium react with hydrochloric acid. So the first one, we need to write the correct chemical formula for aluminium chloride. So aluminium has a valence of 3, chlorine has a valence of 1. So if we use the crisscross method, the chemical formula will give us aluminium chloride with a subscript of 3 plus C. The hydrogen is always diatomic. Right, so we need to first begin by balancing the metal. So aluminium, there is only one atom here. Also, there is only one atom here. So the aluminium is balanced. What of the hydrogen? Hydrogen, there is 1. Hydrogen, there is 2. Then chlorine, there is 1. Here, there is 3. Now for this one, we are going to first balance the chloride, which is the chlorine. So what do you do? We need to divide this by 1. So this will give us 3. So we need a 3 in front of HCl. Now if we have 3 here, now how can we balance the hydrogen? So the hydrogen we need to balance by 3/2 as a fraction. Then for aluminium is balanced. So for aluminium, this one is balanced. Now remember, we only need to use the O number. So we are going to do the same. We need to multiply everything by 2. So begin by 2 multiplied by aluminium. So this will give us 2 La plus, then the second one, 2 times 3, giving us 6 HCl. Then we move on to 2 times this one, will give us 2 LCl3 plus, if we multiply 3/2 times 2, the 2's will cancel. We have 3 times H2O, H. So as we can see, our equation is now balanced. Okay, so we get another example. So another example, let's get, we have sulfur dioxide reacting with oxygen. Then we know that we are going to have sulfur trioxide, SO3. So tri, it means 3 atoms. Then for this one, how can we balance this one? So let's check for sulfur. So sulfur is 1. Then also here is 1, so sulfur is balanced. Now for oxygen, we have 4. Then this side we have 3. So how can we balance the oxygen? So let's put a 2 in front of sulfur trioxide, so that we have 6 atoms of oxygen in sulfur trioxide. Then 2 atoms of sulfur, we can also just put 2 in front here, so that we have 2 times 2, 4, plus 2, we have our 6 atoms of oxygen. Then our equation is balanced. Now let's say we have a double displacement where we want to look at sodium phosphate. So phosphate has a valence of 3. Then we have the radical plus we are reacting with magnesium chloride. Then we are going to have sodium chloride plus magnesium 3. Then phosphate. Now for if you have a radical like hydroxide, phosphate, sulfate, the best way that you can do for each compound that has that radical, consider the radical as one thing. So for phosphate and oxygen, we are going to just consider this one as a one component. So look at this one. So on this part here, it means that we have 2 phosphate. So if that is the case, we need to look at on the reactant side where there is phosphate, so there is this, but we need 2 of this, so we are going to put 2 in front of sodium phosphate, so that these 2 gives us the picture of these 2 phosphate. Then if we put 2, we know that 2 times 3 will give us 6, so we need 6 atoms of sodium on the product side, so let's put 6 here. Then what of chlorine? Chlorine here, it means we have 6 atoms of chlorine in the sodium chloride, so we can just put a 3 here, so that if we multiply 3 times 2 will give us 6, then 3 times 1 will give us 3, and we know that here there is 3, so our equation is now balanced. Let's check here another example. So let's say we have this is the calcium sulfate plus we are reacting this one with aluminum chloride. So this is also a double displacement, and the calcium is more reactive than aluminum, so this will give us calcium chloride plus the aluminum sulfate. So for this one, we can see that the sulfate is 3. So we have 3 radicals of sulfate. So we need to put 3 in front of the compound where we have the sulfate. So the compound that has the sulfate is potassium sulfate. So we put 3 here, so that we have 3 of these radicals. Now this changes the number of atoms of potassium. 3 times 2 is 6. So we need 6 here, so that 6 times 1 will give us 6 here. Then 6 times 1, 6 atoms of chlorine. Then we are going to put 2 in front of aluminum chloride, so that if we multiply 2 times 3 will give us also 6. Then here 2 times 1, it's 2. Even here we have 2. So this is our balanced chemical equation. So now let's look at the last example. So the last example is we have ammonia reacting with oxygen, giving us nitrogen monoxide plus H2O. So we'll begin by first balancing. Nitrogen is balanced, then hydrogen is not balanced. So how can we balance these atoms of hydrogen? So to balance these atoms of hydrogen, we can put 2 here, so that 2 times 3 is 6. Also 2 here, so that 2 atoms of nitrogen. Then 2 times this number is 6, so we put a 3 here. Now I said whenever you have a single element, like for our oxygen, it's easy to balance that one, so that one shouldn't give us that headache. So let's look at the number of atoms of oxygen on the product side. So we have 2 times 1, so 2 from nitrogen monoxide plus 3 from water, which is giving us 5. Now we know that 5 is an odd number, so it means we need 5 over 2. Now since we don't need the fraction, we are supposed to now multiply everything by 2. So our final answer will be 2 times 2 is 4 ammonia molecules. Then 2 times 5 over 2, the 2 will cancel. So we have 5 O2. Then 2 times 2 will have 4 molecules of nitrogen monoxide. 2 times 3 will have 6 molecules of water. So this is what you are supposed to do. So to summarize our answers, if you are dealing with an organic compound where we have carbon, make sure you first begin by balancing carbon, hydrogen, then oxygen. You consider that one the last one. Then for ionic compounds where we have metals, make sure you first begin by balancing the metals, then after that you proceed. So this is what we can share for this video. Thanks for watching.